An inverse of a matrix is a matrix A to the power of -1 such that when we multiply our matrix by its inverse, we get 1. Think of it like the reciprocal of numbers. For example, if we multiply 5 by 1 over 5, its reciprocal, we get 1. Multiplying a matrix with its inverse, we get the identity matrix. And note that the inverse of a matrix only exists for non-singular matrices where the determinant is not equal to 0. Let's take a look on the identity matrix I, right? An identity matrix is a matrix with 1s on the main diagonal and 0s elsewhere. This identity matrix is equivalent to the number of 1 such that when we multiply a matrix by the identity matrix, we get that matrix. For example, we are given the matrix with elements 3, 2, 1, and 4, and if we multiply it by the identity matrix I, we're still gonna get a resultant matrix with elements 3, 2, 1, 4. Ngaticherechedze kutsvaga inverse yematrix. Takapiwa matrix nema-elements A, B, C, and D, and the formula for its inverse is given as 1 over what? AD minus BC, which is just the determinant and it. Multiplying matrix redu ranga takapiwa, but we've swapped my elements ari main diagonal pedu, and my elements angasiri pa main diagonal have now attached my negative signs. So the four steps of finding the inverse of a matrix are: chekutanga, you write down your matrix A. The second step is you calculate the determinant using the formula AD minus BC. The third step will be to swap A and D and you negate B and C, meaning the attached negative signs. And the last step is to multiply your new matrix by 1 over the determinant. Let's take a look at calculating the inverse of matrix A. So chekutanga, we find the determinant using the formula AD minus BC towana 10. The second step is to swap and negate. So we swap my elements at position A and D, and the rest of the elements are not attached. We attach what? A negative sign. Then lastly, we're going to say 1 over the determinant of 10 multiplied by our swapped matrix to get our resultant inverse matrix. Note that our determinant was not equal to 0, meaning our matrix A was a non-singular matrix, hence it has an inverse. So for the second example, we are given a matrix with elements 3, -1, -2, na 1. Chekutanga again tinotsvaga determinant redu. Then second step to swap and nekunegata and to get a matrix with elements 1, 1, 2, 3. Then finally we are going to say 1 over our determinant multiplying our swapped matrix, and we get the inverse of A as 1, 1, 2, 3. We also need to take note that the determinant redu was not equal to 0. That means the sure matrix redu rene inverse. For our last example, we are going to follow the steps of the previous two examples, working out determinant to get -1 and then multiplying by our swapped -1, 2, 3, and -5 as our determinant. For verification of our inverses, if we multiply our original matrix by its inverse, we should get an identity matrix. So our first example checks out, and let's check again for our second example. Our matrix A multiplied by its inverse again is resulting in an identity matrix, so we were correct. Then for the third again, if we multiply it by its inverse, we are getting an identity matrix, so we were correct again. So summarizing on our lesson, we looked on definition of the inverse of a matrix, its identity, and the condition that is to be met for us to find the inverse of a matrix.